Thanks, Tanya. I hope the colleagues online can hear me well. Yes, perfect. So thank you again to the Trump Foundation once again for the award, the Trump Award for Young Scientists. And thanks again for inviting me to present at this workshop today. So the aims of my research are to assess the number, the frequency, the intensity and magnitude of heat waves and cold waves in Ireland based on quality controlled and homogenized instrumental data from 1885 up to now. And then based on documentary data, create an open access database of the impacts of heat waves and cold waves across the island of Ireland from 583 up to 2024. And these are based on documentary source, so weather diaries, meteorological publications, and the newspapers. And then having these instrumental data and documentary source, I'll be able to identify maximum extremes and rank the most severe and impactful events from historical record. Look at patterns in the individual impact categories, and then also assess any change in the temporal and the distribution of heat waves and cold waves in Ireland. And then, of course, see how the vulnerability is changing throughout the time. So Ireland has a rich history of historical meteorological observations. So these observations, they date back to the late 1600s. But when you are talking about temperatures, you have temperatures dating back to the 1700s, and then daily maximum and daily minimum temperatures from the 1850s. Sorry, from the 1800s. And here you can see the geographical distribution of the historical meteorological observations. So my first step, I had to go to these different libraries and archives to identify daily maximum and daily minimum temperatures. Then I had to transcribe these observations from historical manuscripts, and they look like this. Here you have some examples of the historical manuscripts. So I had to transcribe all of these observations into Excel files and also look at metadata. So metadata are information about the data. So information about the instrumentation, observation practice, and this type of information is very important to assess the quality of the data. So as I said, I had to transcribe these observations. These observations were double keyed to avoid any errors in the data transcription. And I also engaged university students and also high school students, so secondary school students in this transcription. And this was part of an outreach project. The next step was the quality control. So I look at climate consistency, internal consistency, persistency tests, also step change tests. So these tests were developed in R, and flagged data then was cross-referenced with the documentary source. As you can see here, an example of a historical newspaper. And then the data was homogenized using MASH software. Now, before you look at heat waves and the cold waves, let's have a look at the trends in temperature. So here are the trends in the seasonal and annual maximum and minimum temperatures across Ireland from 1885. And then these values here are the average for Ireland. So overall, you can see increasing trends for both max and minimum temperatures, with a greater warming overall in the minimum temperature. When you look at daily extreme air temperature indices, these are known as 16 climate change indicators. So you can see overall, you see a decrease in the cold days, cold nights, frost days, ice days, and then an increase in the warm days, warm nights. Also an increase in the warm spell duration index, growing season length, and then you also see a warming of the coldest night and a warming of the coldest day. And then also a warming of the hottest day and hottest night. Now looking at the trends in heat waves and cold waves. So I look at different indices. So I looked at the definition used by MATEUS. So we have to consider the climate of Ireland, the oceanic climate. So I look at definition used by the National Meteorological Service, MATEUS. So it considers a heat wave with at least 5 or more consecutive days when the daily maximum temperature is over 25 degrees Celsius. I also look at definition used by the UK Met Office, excess heat factor based on the 19th and else 95th percentile, and then the 19th percentile of daily maximum temperature. So um, different definitions, and then I look at the number, so how these heat waves are changing across the summer season throughout the time, the frequency, so how many days we have within a heat wave, the duration, so this case it is the maximum duration, the magnitude, that's the average temperature of the days in a heat wave, and then the amplitude, the maximum temperature value. And then for the cold, I look at the excess cold factor and then the 10th percentile of the daily minimum temperature. Because I have many definitions and many stations across Ireland, and these work is still in the process of publication, I'm presenting here the results for a station in Dublin. And why? Because that's where you have the highest concentration of population, so demographic density. So you can see when you look at the number across these three definitions, overall we see an increase in frequency of heat waves. So looking at the excess heat factor, based on 19th percentile, we see the heat waves are 5.4 times greater in 2023 in comparison to 1885, 2.9 times greater if you consider the 95th percentile. And then the 19th percentile of daily maximum temperature, here we have 1 point times greater. In terms of the frequency, so here again we are looking at the number of days within a heat wave. We have 7 times greater now compared to the start of this record in 1885. When you look at the excess heat factor based on the 1950th percentile, we have now the frequency as 4.1 times greater. And the 19th percentile of the daily maximum temperature, we have 3.5 times greater. Looking at duration, so we are looking at the maximum duration, so we see an increase in the duration. Also, all of these values are statistically significant. So you see values ranging from 3.2, 2.9, 2.3. And then the amplitude, so the amplitude, we are looking at the peak. So the odds of at least one heat wave per year is nearly 8 times greater now compared to 1885. And the amplitude of heat waves has risen by 3.7 degrees Celsius over this period. In case of the cold, we are looking at one definition here, the excess cold factor. Looking at the number, we all see a decrease in the number, annual decrease of 0.55%, and frequency, annual decrease of 0.63%, duration, annual decrease of 0.43%, magnitude. Here you see the heat waves are expected to be 2.72 degrees warmer. So degrees Celsius, so warmer now compared to 1885. And then amplitude, you see a warming of the amplitude. And here you see a warming of 12.26 degrees. And you might think, well, that's a lot. But the lowest minimum air temperature on record for Ireland is minus 19.1 in January 1881. So you can see there is a big difference between minus 19.1. So overall, you are seeing a decrease of the peak of the lowest minimum temperatures that you see during cold waves. Hence, these big warming, okay? Now, the second part of this research is to look at documentary source. So again, looking at this documentary source is very important to expand the analysis of the duration, frequency, intensity, and geographical distribution of heat waves and cold waves beyond the quality controlled and homogenized instrumental record, but also to look at impacts and also look at how the vulnerability changed throughout the time. So to look at this documentary source, I used the historical manuscripts. So you can see here the geographical distribution of these manuscripts before 1900. 1900. Also, I had a look at newspapers. So these are historical newspapers published online, so they are digitized, and they were published between 1704 and now. And I used the British Newspaper Archive, which has a huge collection of newspapers, so 268 newspaper titles, publications, so annals, so beyond so before 1704, I had a look at weather diaries and annals, other monographs, to have a look at these impacts. And then the goal is to have an open access database where you have, again, hundreds of events for the cold waves, heat waves, and then you have a column for the location, and then another column where you have the exact quotations from these newspapers, from these weather diaries, manuscripts, and the exact source, and then a column with this summary of impacts. So let's say you have these categories, let's say impacts on transport, impacts on health, when you have mortalities, impacts on farming, and so on. So then stakeholders, instrument makers, they are able to see for the first time a comprehensive database on the impacts of these extreme air temperature events in Ireland. So here are some examples of these data source. So here we have a manuscript from January 1807, and then another manuscript from January 1784. So you have a mix of instrumental data and also qualitative data. A newspaper, so Dublin Courier, from February 1766. So again, newspapers, they are very good to have a look at the exact duration of these events. Again, you might have daily newspapers or weekly newspapers, and then you have an idea when you have the start and end of this event. And then you have a good description of the geographical distribution as well. So back then, newspapers, they would be the social media that you have today. So newspapers are a very good source to look at the duration, the intensity, and the impacts. So again, I'm using these newspapers to look at the description of the events. So let's say the start date, end date, so the duration, geographical distribution, but also the impacts. So this work of the analysis of documentary source is still ongoing, but here you can see an overall summary of impacts of these events in Ireland. So overall heat waves, they include a greater water consumption, water shortage, and we have seen these in the last events of 2018 and 2021. So there were many house pipe bans, so in terms of the water consumption. And then these events, they are quite serious when you have a heat wave combined with a drought event. We all see a greater energy demand, impacts on the farming, heat stress in cattle, and higher risk of forest fires. In the case of the cold waves, so cold waves in Ireland, they are more severe when associated with snowfall events. And in terms of the impact, we have, again, interruption of access to facilities, such as roads, railways, an increase in cattle mortality, sometimes human mortality, reduction of food supplies, isolation of village, cancellation of flights. Of course, it's very interesting to have a look at the historical source because you can see how the vulnerability has changed throughout the time. So now you might see, okay, we have a cancellation of flights, interruption of electric power, but hundreds of years ago, you had the impact. So let's say the roads were not accessible, but then instead of cars, you had like horse carriage, for instance. And then, of course, people, they could not move around, or even if you had lakes, the lakes were frozen, you had no boats transporting grain. So again, you could have the impact of the grains be more expensive, people without access to food. So it's very interesting to see how the vulnerability changed throughout the time. Now, because I have many events and that I'm conscious of time, I'm only highlighting a few examples. So here you can see the example of December 1739, January 1740. So this was a big cold wave. So here you can see this description. Again, you have a good idea of the duration. Again, the intensity. So again, here you can see Lough Neagh was frozen. So that's a big lake in the north. And also you can see some impacts as well. January 1814, so another cold wave. So in this case, we also have a description of the thermometer observations. So that's very good to have these descriptions. In case of the heat, here an example from June 1826. Another examples could be 1846, for instance, 1868. Again, very good information about the duration. Here you can see this heat was not very common at that time of the year. And here you also have an example of the thermometer observation. So these values are in Fahrenheit. So a very nice example of impacts. So as I said, the goal is then to make this database open access. And that's everything from me. Thanks so much.